Okay, so this video is going to go through the most important things for the TI Nspire with calculus, defining functions and finding derivatives, etc. So if you go into your calculator page, we can define functions by going menu, actions, 1, define, and I can call it f of x or g of x or whatever. And you have some rule, say it's x squared plus 1. Now I can find the y value if x equals 2 or 3 or whatever by just going f of, say, x equals 3. What happens? You get 3 squared plus 1. You get the y value being 10. Okay. We can also find the derivative function from this, and it might be useful to define the derivative function, so maybe call it d of x or something. So d of x equal to menu, calculus, derivative of x of f of x. Okay, let's just check what it is. D of x is defined as 2x, which is what you should expect if you know your differentiation rules. Okay, so bring down the power, subtract 1 from the power, and with a constant that goes to 0. So the derivative is definitely 2x. Now you could be asked to find the gradient at a point, or the gradient of a tangent line at a point, which would be just, if x was 3, be d of 3. The gradient of the tangent line at x equals 3 is 6. You can also then use this to find stationary points if you want. We can go menu, algebra, solve where the derivative is equal to 0 for a maximum or minimum. Solving for the x value gives you, in this case, x is 0. And then if you want the corresponding y value, you would just chuck in f of 0, which gives you 1. Okay, let's just check a few of those things, okay? So if we go home and into graphs, here's f of x. Alright, and if I go tab up, go back down. If you go down now, you can get something else. If I'm now graph of d of x, okay, d of x is the red line, and that is corresponding to how the gradient changes of this blue line here. Okay, so up here the derivative is negative, the gradient of the tangent line is negative, so down here is some negative value. Here is the stationary point, or we have a tangent line being just a perfectly horizontal line where the gradient is 0, rise on run is 0, so the red line is 0 there. And up here, you have a positive gradient, and the derivative is positive here. Okay, if I want to delete one of the graphs, I can go tab up and just delete it. Okay. And now let's find equations of some tangent lines. So previously, I found the derivative at x equals 3, which would be the gradient of the tangent line at x equals 3. So the gradient of the tangent line is 6. Let's find the equation of the tangent line at x equals 3. If we go menu, calculus, tangent line, the tangent line of f of x at, use comma, x equals 3, okay, I get the tangent line being 6x minus 8, where m is the gradient here for a straight line, 6 and 6. So if I go control right and I put in that graph, 6x minus 8, okay, does it look like it intersects along x equals 3? Well, you can drag it around a bit, and it does look like it does. Let's just prove it. Menu, analyze graph with the intersection between the two. Click to the lower bound, drag across, click. Yeah, so at x equals 3, the two lines touch. And how would you find this y value here? Well, if you chuck it in to either the red line or the blue line or the equations, you're going to get a y value of 10. So if you chuck in 3 here, 18 minus 8 is 10, or also into the original function, if you chuck in 3 here, you get 3 squared plus 1 is 10. Okay, we can also find the equation of the normal line, which is the line which is perpendicular to the tangent line, by going menu, calculus, normal. We want the normal at the function of x equals 3. Sorry, x equals 3. Okay, and I'm expecting the derivative to be minus 1 on 6, so the negative reciprocal of this one, if you know normal lines properties with gradients. Okay, so the normal line. Here we've got an issue, okay. We don't want this decimal variation. We're going to have to change the settings. Okay, for math methods in Australia, you want exact values where you can. Okay, so flat 12 is good, but you need to have it in radians most of the time when dealing with circular functions. Unless they tell you it's in degrees, you need to change it. And then we also want the calculation mode to be exact. If I make that default now, that will keep that. So now if I go current, if I go up, up, and then enter, that will now give you my exact value form. So in this case, the equation of the tangent line, normal line, sorry, is y equals minus x on 6 plus 21 on 2. Okay, I could define the normal line if I want, but I'll just type it in. Let's go tab, control divide if you want the fraction symbol, 21 on 2 minus x on 6, or just 21 on 2 like this, and then minus x on 6 like this. Okay, let's drag across, and we see that the black line here and the red one kind of look like they're at right angles, which means perpendicular or normal. Okay, so I guess that's the main functions, but you can also solve inequalities, not just equalities. So say you wanted to know where the gradient was negative, we can go menu, algebra, solve. We want the gradient being negative, so d of x I've defined as less than 0. So let's go control equals less than 0, solving for x. Okay, and that tells me that x is less than 0. And let's just look at the graph here. Well, at x equals 0 is a stationary point, and all of the values for x less than 0, you have a negative gradient. So that one works. Okay. What else? I think that is the main things you need to know with gradients. So if you want exact values, you're always going to have to use solve. You can't get, as far as I know, exact values of turning points, etc. Say that was really ugly, like a decimal value, or root 7 or something. It'll give you a decimal approximation. If you go menu, analyze graph, minimum, click on this one, click, click, gives you the minimum. Yeah, okay, so let's just review. You can define your functions, and then you can plug in values, define y values. You can define the derivative, and then find the gradient at any single point. Okay, that would also be called the instantaneous rate of change at a point, or the gradient of the tangent line. You can solve for stationary points. Okay. You can find tangent lines equations where this is y equals 6x minus 8. And you can find the equations of the normals where they're lines which are perpendicular to the tangent lines at a point. And you can also solve inequalities, so solve for all the x values where the derivative is negative or has a negative slope for the tangent line. Okay, so that's it.